Our topic will be the discussion based on trigonometry in China. Where did it come from? Early studies of triangles can be placed to the 2nd millennium BC in Egyptian mathematics. However, mathematics in China emerged independently and properly by the 11th century BC. The Chinese independently developed very large and negative numbers, decimals, a place value decimal system, a binary system, algebra, geometry, and trigonometry. The knowledge of Chinese mathematics before 254 BC is somewhat fragmentary. In other words, information was somewhat disconnected and understanding was little, and even after this date their manuscript traditions are obscure. But what was traced before 11th century was the study of Aryabhata tables. The basics of these are addition, subtraction, multiplication, and division, although this subject also includes more advanced operations such as manipulations of percentages, square roots, exponentation, and logarithmic functions. Although this Aryabhata table was originally from an Indian mathematician. However, Chinese mathematicians got a hold of the Aryabhata tables of signs and were translated into the Chinese mathematical book of the Kaiying Xiangxing, which was a book that contained astrological and divination material, compiled in 17 AD. Although the Chinese excelled in other fields of mathematics such as solid geometry, binomial theorem, and complex algebraic formulas, early forms of trigonometry were not as widely appreciated as in the early Greek, Indian, and Islamic worlds. Chinese used an empirical substitute known as Chongcha, while practical use of plane trigonometry and using the sine, the tangent, and the secant were known. The embryonic state of trigonometry in China slowly began to change and advance during the Song dynasty from 1960 to 1279, where Chinese mathematicians began to express greater emphasis for the need of spherical trigonometry in calendarical science and astronomical calculations. Since the Shang period, which was 1046 BC to 1600 BC, the Chinese had already fully developed a decimal system. Since early times, Chinese understood basic arithmetic, algebra, equations, and negative numbers. Although the Chinese were more focused on arithmetic and advanced algebra for astronomical uses, they were also the first to develop negative numbers, algebraic geometry, and the usage of decimals. Since the Shang period, which was 1046 BC to 1600 BC, the Chinese had already fully developed a decimal system. Since early times, Chinese understood basic arithmetic, algebra, equations, and negative numbers. Although the Chinese were more focused on arithmetic and advanced algebra for astronomical uses, they were also the first to develop negative numbers, algebraic geometry, and the usage of decimals. Who wanted to find the answer, and what did they want it for?
In in Chinese mathematics, we can see two main contributors, Shen Kuo and Guo Shouying. Guo Shouying was born in 1231 in Xintai Shunde and died in 1316. He was an astronomer and a mathematician. Guo Shouying began studying astronomy, mathematics, and hydraulics with his grandfather Guo Rong when he was a child. He used trigonometry to solve problems of chords and arcs. Guo Shouying worked on arcs and circles, which formed the foundation of spherical trigonometry, which is a branch of spherical geometry which deals with polygons, especially triangles, on the sphere, and the relationship between the sides and the angles. This is of great importance for calculations in astronomy and Earth's surface, orbital and space navigation.
We have the second mathematics called Shenku, 1031 to 1095 AD. Shenku mastered many practical mathematical problems, including many complex formulas for geometry, packing equations for calculus, and chords and arc problems employing trigonometry. He wrote extensively about what he had learned while working for the state treasury, including mathematical problems posed by computing land tax, estimating requirements, currency issues, metrology, and so forth. Shen once computed the amount of terrain space required for battle formations in military strategy, and also computed the longest possible military campaign, given the limits of human careers who would bring their own food and food for other soldiers. Shen Q also experimented with the pinhole camera, although the Iraqi Muslim scientist Ibn al-Haytham, born in 965 to 1039 AD, was the first to experiment with camera obscura. Shen Q was the first to apply geometrical and quantitative attributes to the camera obscura, just several decades after Ibn al-Haytham's death. However, some of his most impressive written work in mathematics would be applied to his work in astronomy. When looking back, we see how trigonometry has a topic for daily use. For example, it is the biggest impact that trigonometry has had in astronomy is in the finding of distances to nearby stars through the method of parallax. As you know, the Earth orbits around the Sun once a year. This means that at 6-month intervals, the Earth is looking at a star from the two corners of an isosceles triangle, where the point is at the star. We can observe how far the star appears to move against the background galaxies in that time and find the angle of the triangle from that. With the angle and the length of the base, the diameter of the Earth's orbit, we can find the height of the triangle or the distance of the star. Also, trigonometry helps surveyors determine sides of a triangle which are either inaccessible or difficult to access. Knowing the length of a single baseline enables the surveyor to define the other elements of the triangle by measuring the angle to the inaccessible points from accessible points. Consequently, the height of trees and tall buildings can be determined by knowing the distance to the base of the tree or building. Similarly, locations separated by, for example, rivers or busy roads, can be determined by angular measurement from positions of known distance apart on the other side of the obstruction. Survey control marks used for the mapping of countries were in the past established by triangulation from a known baseline. These days, much of the survey control is undertaken using GPS equipment, which is used by satellite signals to determine positions on Earth. However, the theory behind the location of these positions also uses trigonometry and spherical trigonometry. When we look at how Chinese trigonometry was used and the finding of arcs using simple tools or astronomy, I can only say that the formulas of today are no different. In fact, what would there be to improve on the formula if we can already find distances between angles and lengths? The only difference we have in modern day is the use of different tools, and by these tools, ones that make it easier for humans to cooperate with. Taking a look at this formula from Zheng Q, he advanced this formula of the arc circle, S given the diameter of D, sagitta V, and the length of the chord subtending the arc. He called this method the technique of intersecting circles. The only difference today with this formula would be using technology to determine the results based on the formula.